we're going to move into organizing instruction and study. Now, a lot of what we're going to talk about in this next section has sort of been built, and you'll see the connection from the beginning or the early session this morning. But one of the things that we need to consider is how we help our kids remember. Now, we all should know what the quadratic formula is, right? All right. And there's a song that we can sing it, right? So, how do we help our kids remember? Well, one of the things that we sort of have to get out of, or one process we can often do, is, that's what the quadratic formula is. And, how do we help students remember that quadratic formula? Well, we can follow this sort of dialogue, which is, okay, remember, note also that it's 2a at the bottom of the formula. It's underneath everything above, not just the square root. And don't forget that it's 2a under there, not just a 2. All right? And then make sure that you're careful not to drop the square root. It's plus or minus. We go through, remember, 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 remember. Now, we violated a lot of good instruction there because we told them what they shouldn't do last. We're almost guaranteeing them they're going to mess it up. So, a lot of times that's what we do. Or we could say, you know what, just derive it yourself. And we can teach them to derive it ourselves, because we all want to complete the square to derive the quadratic formula. No, I don't think so. Well, okay, so we have, all right, technology to the rescue. Google quadratic formula calculator. It'll come up. You just put in your numbers, A, B, and C, and it'll give you your answers, all right? So those are all things we can do. Or we can be a little bit more strategic and give them devices, structure to help them remember the quadratic formula. Now, I tested this out on my mother. All right? She's had it with high school algebra. And I was up home and I said, I'm going to teach you the quadratic formula. And of course, she rolled her eyes, kind of like probably what I did when I was a teenager. So I showed her this mnemonic, this picture representation, minus b plus or minus b squared minus 4AC, or 4 aces, all over TWA. Remember that airline? 2A. So I taught her that, and we were at the beach this last summer, and I said, Mom, do you remember the quadratic formula? And she says, oh, I hate that thing, but there was a B minus a B, and she remembered the equation because of the visual image, all right? And then, of course, there's a quadratic formula song that you can Google. And there's all kinds of songs, by the way, about math on the internet. But what we have to do is we need to come up with better ways to help kids remember things. Now, with this sort of picture, does it teach them anything about the quadratic formula, why you use it, how you use it? No, it teaches them to remember it, all right? And that's part of helping kids remember. And, we need to differentiate instruction for all of these reasons. I don't have to tell you why we need to do this with everything that you're under as far as pressure is for teachers. We also know that all kids are different. One size will not fit all, including a pacing guide. We need to sort of differentiate, accelerate as we need, reteach as necessary, and to give all students access and success in the curriculum. And with differentiating instruction, some of the things we have to remember, not all students are alike, and that we must sort of meet their needs whenever we can have that challenge, and that in your classroom of 25 kids or 30 kids, there's a whole range of prior knowledge, prior experience, motivation, and so forth, differing ability, skill level that we sort of have to try to address. And that becomes very challenging. But with differentiated instruction, you start to see that it has a lot of the same characteristics as sort of explicit instruction, where we're working in whole class, small group, individual, and your approach really depends on the individual needs and the content that we're trying to teach. It has to occur prior to class starting. We must adjust curriculum when necessary, adjust instruction as you see it, practice opportunities, homework, testing, the whole 9 yards. We cannot expect students to change to our teaching. All right? That's something we sort of have to, we are there to work with the kids. And just, I'm sort of refreshing with this teachers must maximize the capacity of all of their students. You're going to have students that come to you that, you know what, you're going to work your hardest to maximize their learning. And some kids, it's easier than others, while the ones that are really challenging have all kinds of variables that are affecting their performance. But we're trying to maximize student learning. And we are trying to challenge learners at the same time. We don't always want to focus on the lower achieving kids or the average, the middle of the road, but also accelerate kids. Gifted kids are probably some of the most underserved in that they end up doing a lot of stuff independently. Why? Because they get it and they move forward. So we've got both ends here. Differentiating actually came out of the gifted literature as trying to accelerate those kids. So we want to maximize. Well, there are various, I'm going to go over 5 techniques to maximize student learning that sort of can fall in this umbrella of differentiated instruction. But within differentiated, and we've talked about this, scaffolding, personally, differentiation is along the same lines as scaffolding. It happens before the class starts. Knowing your students, their strengths, weaknesses, will allow you to better differentiate. It's also student-centered, being on the fact that we're looking at our students and their performance and then moving out from that. But where I want to get to is, you know, a lot of what we do is helping students to learn new information, but also helping them to not forget the other information that we taught. And that's something that's very, very important. And we want to sort of stop the chicken teaching. Now, do we know what the chicken teaching is? You've taught your lesson, their independent work, and as soon as they get to their independent work, what starts to happen?
Yeah, everybody needs something.
And then you come over, and you're walking around at every table, you're doing the chicken. We've all done it. Don't tell me you haven't. And if you haven't done it, chicken teaching, then you've done this. Uh-huh. Yes, I know. So we have to try to work smarter, not harder. And keeping in mind, we still have high expectations. We need to help kids remember. We need to help organize their study time, their practice, motivation, the whole 9 yards. Well, there's 5 recommendations that I'm going to go over here. And some of these are more common sense. Others are sort of what the literature as far as is telling us. And the one that, in my opinion, when I first read it, number 3 here, I was mad. Because I had been a math teacher, I have studied math in my doctoral program, and I had not heard of this. And this is something that I hope, if any of you take any away from this workshop, that tomorrow, when you go to class, you do number 3. And we're going to talk about that here in a second. Motivate through technology. One of the biggest things that reported from the algebra survey was that unmotivated students is a challenge. Now, I have no earth-shattering information here, but one of the things that we must think about is think outside the box to motivating kids. YouTube, you've all heard of it, right? Your kids are on YouTube, I guarantee it. Now, I'm on YouTube searching things like Pythagorean theorem, differentiating equations. They're searching other things. How many have used YouTube for educational sorts of activities? A couple? There are hundreds, possibly thousands of 10 to 20-minute video clips focusing on math available on YouTube. All right? There's this person here called this video math tutor. He literally, in about as an explicit fashion as possible, will focus on a skill or a concept, teach it, show examples, have some guided practice, and take them through the progression. Your middle school and high school kids may not want to listen or hear a word you say, but as soon as you say, check this out on YouTube, they may instantly be motivated. All right? This is also a great way to enrich kids that are really good in math. Have them come up with a lesson and put it on YouTube. All right? Now, this is purely to try to get kids motivated. If you're going to do any of this stuff with videos, you, of course, have to make sure you follow your school district procedures for videotaping and those types of things. But it's there. Your kids are using it. The ones that are strategic and can find help. On YouTube, you can actually post comments, and I just went on there and did a screen capture. Here's a comment here. This helps a lot. I'm taking algebra in 5 days, and I'm going into 8th grade. That was easy, thank you. That's an 8th grader that went on YouTube, looked at solving some algebraic equations, watched the video. Some of these videos are very professional. Some of these videos are not. Your kids are on YouTube and these types of websites. Take advantage of it whenever possible. Now, most school districts are going to filter these types of things, so you have to get it outside of class and bring it in class if you're going to use it. But this is something that you can motivate. You can activate prior knowledge. You can have kids show them resources where they can get extra help. Lots of things that are out there. I have a school that I'm working with where the teacher has it set up, middle school teacher, every lesson is videotaped. Every single lesson is videotaped. She has a kid come in the class. His job is to set the video camera, put it on. When she's done, another student takes the video, uploads it onto the district website so that they can have access to her lessons through the internet. All right? Take advantage of technology as much as you can. It's not that complicated. Your kids are using it, and it's something that we need to tap into. So motivate, think outside the box. There's only so much you can do motivating in classes. But your kids are on YouTube, these social networks, tap into it. That in itself may open some eyes, get someone interested. You never know. And it's something that's easy, it's free, and it's out there. All right. Spaced learning over time. This is a very, very powerful way to keep kids on track. And I was listening to NPR the other day, and they had an aging specialist on there, all right? Because when people get old, they tend to lose their memory, right? Or parts of it. And the NPR person was saying, well, I have problems now remembering people's names. And the aging specialist said, well, here's one way that you can practice it. When you meet someone, the first thing you should do is make sure to use their name. The next thing you should do is associate that name and that person with some attribute. All right, long hair, I met Ann, or I met Sally buying sardines. All right, you're making a connection. You're building a neuron connection. Then he said, and then right after they leave, the NPR said, then I should say Sally, 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 right? Say it 10 times, remember it? And the person said, no. You should actually wait 25 minutes and then say her name and that attribute. And then wait an hour later, say it again, and she said, spaced practice. All right? That's exactly what this is. Now, I've called it spaced instructional review, where in math with our struggling kids, we sometimes have to pair this review with instruction. And what the research says is that it's best if you can revisit big ideas twice after the instruction and the first learning takes place, and that's separated by at least 4 to 6 weeks. All right? Now, this is important because usually what happens is we teach a unit, and the day before the test, what do? And what are we reviewing? What was just taught. Now, the purpose of that is to help the kids prepare for the test. And that's fine. I'm not saying doing that. But under this sort of recommendation, you would set up mini lessons where you're reviewing something that was taught 4 to 6 weeks ago. That's that spaced learning over time. In your handout, I've given you sort of a guide that, let's see, it is on it's handout number 8, and it looks like this. This is not set in stone. You don't have to use this. You probably have something like this. But basically, what you want to do to implement this type of spaced learning over time is sort of block out your year. Maybe you do it in 6-week blocks or 5-week blocks, or block out your year. Then list the big ideas that are covered in each block. Now, you already should have that done. It's called the what? Standards or the pacing guide. So you should already have that done. Next is look at those blocks and determine, of these things covered in each block, number one, what's most important. Of course, Anyone who wrote standard is saying everything's important. What is most pivotal, and then what is most problematic for your kids? Now we know one of those is what? Fractions, okay? Identify those areas, develop or decide you're going to address 2 of those across that time span, and then allocate 30 to 40 minutes, maybe less, depending on what it is, to develop some mini lessons to revisit that information or that's topics 4 to 6 weeks after it was initially taught. Everybody follow me on this? This is a little bit different than doing review worksheets or those types of things, as we're partnering it with some instruction. And what the research shows is this is the best way to keep these skills learned, fluent, or proficient, is revisiting. Remember back early on I said, give me a calculus problem. Someone taught me, probably can't. I used to be able to do it, and now I can't. The same thing holds true for here. Now, in the research, when they do these things, what they find is we kind of do this already. We have in-class reviews. You can do it through homework assignments. You can do it if you do a midterm exam and a final exam. I don't know if that's what you have in place. But by doing that, you're sort of forcing the kids to revisit information. Now, one of the things that you have to decide, and when you're looking at what areas are problematic, where you want to focus on, first off, you can't do it all. You've got to focus in. Some things are automatically reviewed because you continually use them throughout. That's not something then you want to target. But really sort of prioritize. This is where you want to use your CRCT data from the year before, any other pre-assessments or progress monitoring measures that you use. Identify the weakest areas. Target those with instructional lessons that will go back and space the learning of that particular concept over time. Now, when you look at this, a couple of things, you probably already do some of these things. Some roadblocks. Textbooks don't do this very well. State standards don't, in the sense that most of these things are linear. Teaching it, teaching it, teaching it. We need to sort of build these reviews in. And then this number 2, this is for all of you. When you revisit stuff, expect the kids to look at you like you just, a deer just got in front of your car and the headlights, kind of like, huh? We learned this? That's part of the process. You have to revisit it to bring it, to firm it up at a later date. But this is something that is very powerful in keeping skills in kids' repertoire, which of course is really what we're trying to do, help them not forget. Teachers get very discouraged when they do the research and they survey the teachers. Teachers get very discouraged that the kids don't remember what you've taught. But again, that's why we do it. Now, this is the one that, in my opinion, if you leave with anything today, this is the one that I think has potential to change how we do math. And it goes back to the solutions, giving the kids access to the solutions. Now, interleave, I'll be honest, when I first saw that, I didn't know what that word meant. Remember, I'm a math teacher. I looked it up, but I have a little prompt here. It's like shuffling a card, interleaving the 2 sides of the decks together, every other. What this research basically boiled down to was, if you give kids homework or independent practice, if every other problem was solved, that maximized learning. And the research, you know, things that are simplest are best, they basically took a group and they divided it down the center, and that half had the traditional homework assignment in math, 1 to 21 odd. They had those 10 or 11 problems solved. Traditionally, that's how we do homework, right? This is where I was at. The other half got 10 problems, and every other problem was solved for the student. And the student was directed to go through the steps of the solved problem. Everybody follow me? You still had 10 problems, but you only solved 5. The other 5 you looked at. And guess what? This group outperformed the other group with 5 less practice problems. All right, now anybody heard of this? You have?
I'm from California, and they have the answer key all in the back, so we always did it that way.
Yes.
We assigned all the problems.
Answer key, solutions. We need to give our kids access to that. Funny, when I was a gifted teacher, I wasn't gifted, the kids were gifted. If they were working on a problem and they had a question, I had the solutions manual available to them. When I was with the non-gifted kids, that puppy was locked away in a drawer and nobody got to it. All right? That's what they need. They need to see the solution. So with this is why I think this was can be very powerful. Is number 1, it doesn't take a lot of work on our part. Number 2, it is relatively supported in the research. Now, I say relatively. The research was done with 8th graders and 9th graders with algebra. The research does not differentiate for LD kids. All right? So it hasn't been done with kids specifically with learning disabilities. My guess is they may need a little more cueing in the solution. The research, some of them just did the steps. Others provided alternate cueing. And sort of, you know, what they did is that they had the solution. Remember back when I just prayed that we got the odd number problems? Because I at least had an answer that I could try to work backwards from. Here, you're reducing the cognitive load of I'm not worrying about the computation, and you're, again, focusing the students on the what? The process. The students also reported that the solved problems help them solve the unsolved problems. Okay? So this is one of my favorite, and you know, there's a long story about this. I was on an airplane when I read this, and I was getting animated because I was mad that I had not heard of this before. The research was done in the late 80s, early 90s, and there was a lady beside me. Finally, she said, "Are you okay?" And then we had a 2-hour conversation, or I should say, I had a 2-hour conversation about how we teach algebra. You know, that poor lady was, you know, I'd rather sit by a screaming baby than some nut from Clemson talking about algebra. But this is something that is simple to do, very powerful, and again, support. Yes?
Do you find it's more useful to do like every other problem than to have one worked out problem at the top of the page where it says, you know, notice you carried this number and whatever?
I don't think they compared the two.
Okay.
I think with this one was, you know, instead of having 10 problems they had to solve, they had 5, and then the 5 were solved so that they could focus on the process and the steps.
Thank you.
Okay? So I think this can improve upon having the example at the top solved. Now, the research on this varied in how much cueing they gave. So some was just the steps, others provided cueing. So you can experiment with that. But one of the things, my guess is kids that are really struggling will probably need a little bit more cueing. Some other recommendations, gradually fade example problems away. Use examples that require greater variability, changing values, you know, mix it up. But I think what the research showed was the kids having an example was very helpful in focusing on the process. Now, how can we extend that to class? Well, we sort of already talked about, you know, initially, maybe the kids aren't writing, but initially, if you're doing a peer tutoring activity or a cooperative activity, the first thing the students look at is a completely solved problem. And then they discuss back and forth. How's it solved? Why you did it? What are the concepts behind it? What are the principles behind it? What are the laws? Then after they explain it, then they go in and they solve one, and then they go back and they explain it. So that's taking from the homework or sort of independent into the instructional class. And bottom line, we need to show our students more worked out solutions is what this really amounts to. Table 8.
With that being said, why do you think the textbooks and the manufacturers went toward providing us with those books that do the problem solving, but they left out the examples because that's what we're dealing with? They give the problems and there's no examples.
My guess is the thickness of the books. I don't know. I don't know. I know, in college, you're in an engineering class or a stats book, you buy the textbook and the solutions guide's made available to you. So I don't really know the answer to that. I mean, we're all math teachers, and many of us have been around for, been teaching with a lot of experience, and we've not heard of this. And this isn't rocket science, it's brand new, it makes sense. If I think back to how I studied for math, is I would look for problems that were what? Solved. I'd study it. Then I would put it away, and what would we try to do? Solve it, and then I'd go back, and then I'd solve the same problem over and over. And that's basically what we're doing with this, is we're giving it to the students. Yes, table 13.
That's one of our parent concerns and difficulties. Our parents are saying, even if they're attempting to help their children, and they look in the book, and they're trying to find some kind of help for their child, they don't even have it in the books that we have now to even use it for themselves as parents to help support their children's learning. So
yeah, I think the solutions, having more access to the solution support. Now, again, we have to keep in mind there will be some kids that then will just what?
They're just going to look
blow
up the
it off,
answers.
copy the solution. I mean, we've got to take that into account. But I think you're right. A lot of parents say, I can't help. So having solutions available can also help as well. So bringing this into the class, having your, putting the example up, looking at the example, having the worked out solution there is important. When we're getting into algebra, the purpose of solving the intersection of two equations, intersection of two lines we talked about, is the purpose to talk about lines intersecting equations, not the computation. And what that turned into was, my kids can't do the fractions, they can't do the computation, they can't do any of that kind of stuff. That interferes with learning the process. By giving them the solution, you're taking that computation off the table. How many are going to do this week? Oh, just humor me, raise your hand. It's something, take a look at it. Co-teaching situation out there, use it. And by the way, this research was predominantly done on 8th and 9th grade kids, not necessarily struggling kids. So it's something that can be helpful for all of us. Again, the roadblocks, and I think you've highlighted it, and so have you, is that we don't have these examples aren't there, and let alone the worked out. That's why, again, you need to have the solutions book. Special ed teachers, you need to have the teacher's edition and the solutions book as well, so that you can have access to that type of thing. All right, let's see. So, here are 3 problems, and what I want to illustrate here is this. I took this from tutornext.com. It's number 1, it's free, so that's always good. But why I like this is you download packets. Okay? Now, this could be construed as a worksheet, yes. But with these packets, there's usually 9 or 10 problems. The front of the packet says problems 1 through 3, easy. 4 through 8, more difficult. 9 through 12, most difficult. Then you flip over, they have the problems. You flip over a couple times, and they have the what? The solutions. All right? TutorNext.com. Teachers like free stuff. That's totally cool. Check it out. And what's neat about it is there's a solution there. Now, if you're going to use any of this stuff, the very first thing you should check is the process and the solution that they're giving is what? In line with what you're teaching, okay? Make sure there's a connection there. They're not made to any curriculum, not to Georgia, any of those kind of things. But, quite literally, the way this works is the kids are given the solutions to every other problem. Kids reported that they were able to finish their homework, a positive attitude, wow, and they did better on tests, all right? So that's one of my favorite recommendations. The only caveat that I have is that they have not segregated with the LD kids to see how effective it is with them. So my guess is they're going to need more guidance. Any questions on that? All right. Tutor Next is where I got those from, and I like it because they sort of help with the differentiation. If we go back to scaffolding, I know I've got some high flyers in there. Do I make them do the easiest problems? Do I make them do the moderate problems? Depends. Maybe you put them right on the most difficult. The other kids, you can start. Maybe we do the easy ones first, then we sort of guided practice for the moderate ones, then the more difficult ones, or however. All right, the next recommendation, connect and integrate abstract, concrete representations. The math panel, the report that I've shown is only about this thick. Well, you can get the full-blown report that reviewed all of the studies. If you have problems sleeping at night, just put that right beside your bed, whip that baby out, you'll be off and sleeping in no time. But one of the things that they really talked about was this concrete to representational to abstract approach. And when you just use concrete manipulatives and go from that to the abstract, there's a disconnect. In other words, kids don't make the smooth transition. And within the research on CRA, concrete, representational, abstract, it's a mix of effectiveness. But the studies that showed the largest effects were studies that explicitly took kids from the concrete to the representative, pictures, types of things, to the abstract. Now, this becomes challenging because math oftentimes is abstract, and it's hard to come up with a concrete model. And some concrete models, especially for dividing fractions, the models themselves are so complicated that it's better to just teach them the abstract. But anytime you can take concrete from representational to abstract, you're going to give a better conceptual understanding with the kids. And when the concrete matches the abstract, that's where you really have a good sort of generalization or application of those concepts. So anytime you can build connections through concreteness, and we'll go back to Robert's oak tree, although since I'm in Georgia, I should have used pine trees, right? The pine. You know, we really focused, and I talked about this a little bit, we focused on the abstract, the numbers and the abstract. But building the concrete model of this thing will get at the concepts of, you know, not necessarily math concept, but understanding that there was something occurring in the first year, that this math problem is representing time across the year and so forth. But building sort of concrete representations and then taking those concrete representations into sort of pictorial representations, and then finally into the abstract. That becomes a little bit more of a challenge with upper level math classes, but you're starting to see, and I know Georgia has a huge initiative in manipulatives, right? Concrete objects and so forth. It's a little tough for us middle school and high school. Well, these are for, you know, babies. I don't want to deal with this. But the research really shows that when you can make that connection, it does strengthen learning for the kids. And again, roadblocks to this, your textbooks, do you have the manipulatives? There's really not a solid series out there that really builds the concrete to representational to abstract. You are starting to see some of these things come out there that are available. Buzzword that you want to look for is CRA. CRA, concrete representational abstract. It has been around for a long time, probably since the 70s. And it's something we sort of got away from. A lot of the reason we got away from manipulatives is what? Not enough time. It takes time to build kids and take them through that progression. But I know Georgia is really pushing manipulatives and sort of giving you that how-to sort of aspect of that. But it's something you need to look at, try to build in. So far we've got try to motivate, YouTube, other things. Spaced learning over time is a very strong way to maximize learning. And then we have that interleaving of work solutions in the problems, making concrete connections whenever possible, and transitioning them through a progression to the abstract. And then another one is re-exposing through quizzes. Now, remember those pop quizzes that we hated when we were in school? You give them as adults? We don't give them because we hated them when we were kids. Well, you know what? Pop quizzes periodically is a way to help the kids keep the information in place. Now, maybe you don't make them a huge part of their grade, but of course you have to walk the fine line. As soon as you tell a kid this doesn't count, what happens? Well, I'm not doing it then. But the research is very clear that closed book quizzes can maximize learning across time. And it's quizzes that require the students to produce an answer versus multiple choice. Now, because of the advent of these end-of-year tests that are all multiple choice, a lot of teachers feel we then need to use multiple choice tests throughout the course of the year. I think that is true to some extent. You need to have a little bit of a balance. But quizzes, periodic quizzes, is a way that really shows to maximize end-of-year performance. And open-ended has been shown to increase achievement on end-of-year tests, okay? Or not, here it's not end-of-year tests, it's end-of-March tests, end-of-course tests, okay. Some things to keep in line here. When you do these quizzes, if you see the kids miss half of it, or all of it, that should be a cue for what? Reteaching. And I know the pacing guide issue, that kind of stuff, but quizzes and so forth, we've sort of gotten into the trap that a quiz, what's the purpose of a quiz? To get a grade. I need to calculate a grade. And yes, that is a purpose. But another purpose is feedback to you as the teacher as far as how your instructional program is going. All right, so quizzes, this can also be done through games. Computer software is out there that can review things, Jeopardy, all of these types of game situations. But remember, really what we want to try to focus our students on is recalling the information. And by recalling it, we're revisiting it, we're refiring up those neuron connections that are in our brain that need to be strengthened, that these quizzes are very important for helping kids retrieve information. So, I've given you 5, is it 5 or 6? I've lost count. This isn't a math workshop or anything. Remember, we want to work smarter, not harder. We want to avoid the chicken teaching. Now, the next time you start doing that in your class, you'll laugh, and your kids will be like, why are you laughing? And you'll say, oh, I'm teaching like a chicken, and they'll look at you. All right. They already think we're crazy anyway because we're math teachers. But those recommendations there are ways for us to work smarter, not harder, to help facilitate learning, remembering, practice for our kids. Now, at this point, I'll ask, does anyone have any questions? And everyone's going, nobody ask anything. All right? I've covered a lot of information. My email is on the front there. It's pjr146@clemson.edu. If you have any other questions or follow-up questions or comments, please feel free to email me. I enjoy hearing back, especially if you come across something that you think really works or want more information. I'm more than happy to share that information with you. But are there any questions in general? You know, one of the things sort of I'll leave you with is a quote, if you always do what you've always done, you'll always get what you've always gotten. And that's why we're here, to try to tweak, maximize, enhance our kids' learning so that in the long run they have a better sort of outlook on math.
Most of us use warm-ups to review. When you talk about reviewing skills, then I can see like maybe setting up a schedule where 4 weeks later you're building in to your warm-up and you're reviewing But would that, like say a 10 minutes review, would that be enough?
I mean, it depends on the kids and the content. My only issue with those reviews, a lot of times they cover 4 or 5 different math concepts at once. It'd almost be better if you sort of did 1 or 2, and then you were able to focus in on those. But I think, yeah, that's a good way to review. But some of those problems, like they call them Fantastic 5 or openers, they're 5 different problems, 5 different math concepts. I think it'd be better if you did 1 or 2, and of course that depends on the kids as well, and then focus on those and build in a regular schedule. Absolutely. Absolutely good. Okay. Thank you very much. You're a great audience.